everyone. Welcome back to HVAC Simplified, where we make complex HVAC concepts simple and practical to understand. Today, we're diving into one of the most powerful tools in the HVAC world, the Psychrometric Chart. If you truly want to understand air conditioning, you need to understand this chart. So, why is the Psychrometric Chart so important in HVAC? Because air is never just air, it's a mixture of dry air and water vapor. And the condition of this air, its temperature, humidity, and moisture content, directly affects comfort, energy use, and equipment performance. Every HVAC process you design, cooling, heating, humidification, dehumidification, mixing, or evaporation, can be represented as a change in air properties on this chart. In other words, the Psychrometric Chart is the map of air behavior. It tells you exactly where your air is and where you need it to go. Once you understand it, you can accurately calculate coil loads, size humidifiers and dehumidifiers, predict condensation, and optimize indoor comfort and energy efficiency. At first glance, the chart looks complicated, full of curved and diagonal lines. But don't worry. It's actually a beautiful combination of all the air properties we use every day in HVAC. Let's break it down one by one. This is the horizontal axis at the bottom of the chart. It's the actual air temperature you measure with a regular thermometer, without considering humidity. In HVAC terms, this is your sensible temperature. It affects how warm or cold the air feels. As you move right, the air gets warmer. Move left, the air gets cooler. Found on the vertical axis, it shows the amount of water vapor in the air, measured in kilograms of water per kilogram of dry air. The higher you go on the chart, the more moisture the air contains. That curved line on the left boundary of the chart is the saturation curve, where the air is fully saturated, meaning it can't hold any more moisture. At this point, the dry bulb and wet bulb temperatures are equal, and condensation begins if the air cools further. Wet bulb temperature is represented by the diagonal lines sloping downward to the right. It's the temperature you'd measure with a thermometer wrapped in a wet cloth. It represents the cooling effect of evaporation. It's very important in HVAC because it tells us how much latent heat the air holds and how much cooling we can achieve through evaporation. The curved lines between the dry air line and the saturation curve show relative humidity, from 10% up to 100%. RH tells us how close the air is to being saturated. For comfort, indoor RH should typically be between 40% and 60%. The dew point is the temperature at which air becomes fully saturated. Any further cooling causes condensation. It's read horizontally across to the saturation curve. In HVAC design, dew point is critical. It determines coil temperatures, condensation control, and comfort conditions. The diagonal lines running almost parallel to the wet bulb lines represent enthalpy, measured in kilojoules per kilogram. Enthalpy combines both sensible and latent heat, giving the total heat content of the air. It's used to calculate cooling and heating loads. These are the slightly upward-sloping lines on the right side of the chart. They show the volume of air per kilogram of dry air. This helps us size ducts and understand how air expands or contracts with temperature and humidity changes. Once you understand these parameters, you can plot real HVAC processes, like cooling and dehumidification moving left and downward, heating and humidification moving right and upward, and evaporative cooling, moving along constant enthalpy lines. The Psychrometric Chart lets you visualize every air conditioning process and make design decisions with confidence. So, the next time you look at a Psychrometric Chart, don't be intimidated. It's not just a bunch of lines. It's a story of air, showing how temperature, humidity, and energy all interact to define comfort. Understanding this chart is the foundation for mastering cooling coil design, dehumidification, load calculation, and energy optimization in HVAC systems. If you found this video helpful, don't forget to like, share, and subscribe to HVAC Simplified, where we make HVAC concepts simple, visual, and practical.